Mg is for micrograms. Ng is nanograms, milligrams, kilograms. You should know what these prefixes are, if you want to call them that. It works for distance also. We deal with the metric system. We deal with the meter. There's a centimeter, that's 1/100th of a meter. Kilometer, that's 1,000 meters. Millimeters, 1/1000th of a meter. Okay, so again, we have to know what these things are. Area is also a unit of measurement, but that comes from a measurement of distance squared. Square meters. That's the common metric amount. I mean, you can also use square kilometers. We're dealing with huge tracts of land, but generally it's like meters, square meters. Volume is also a measurement, but that's distance cubed. That would be cubic meters. That's how it will be measured. That's the standard unit of measurement for volume in the metric system. So some of these units can be combined for different properties. Like we want to measure something, but it's not mass or distance. There are other units like for electrical charge and things, but we're not going to deal with that. There are combined units for measurements that we want to know, like density. Here's an example of how density works. It's an important idea because different kinds of matter are identified by their different densities. Density is, in fact, defined by the mass divided by the volume. Mass divided by volume, mass in grams, volume usually in cubic centimeters. We don't want to use cubic meters because a cubic meter is a really large thing, and we're dealing in a laboratory, for example. We're dealing with things around the size of a few cups here and there. We're not going to deal with cubic liters, cubic meters. That's like a huge thing. Imagine a meter is like around the size of a small table. Cubic meters like that height and that width and that length. That's a huge amount. We generally don't deal with things like that in the lab. So anyway, so we measure the density with grams per cubic centimeter, a milliliter. Now that's a small amount. That's occasionally dealt with in the lab. Very often dealt with in the lab. So we're going to use the units for density as grams per cubic centimeter or grams per milliliter. A cubic centimeter is a milliliter. There's two ways of saying the same thing. Exactly why it's the same thing I'm not going to go into, but the units of density, let's say, are grams per milliliter. You see how we're combining two different units. Grams is a unit of mass, milliliters are a unit of volume. So, but that's exactly what we're measuring, how much mass per volume. So we're going to give the unit of grams per milliliter, even though it's composed of smaller units, the gram and the milliliter. So the density, it's important to know, is a characteristic property of a substance. Now, it's not to say two substances do not have coincidentally the same density, but if you have two different substances, you can pretty much assume that they have different densities. That is, you might recall the story of Archimedes and the king's crown. The king had a crown, was given a crown. I guess he had to pay for it in some way. And he didn't know how it was made. He wasn't watching it being made. It was supposed to be a gold crown, but he was suspected that there was silver that was used instead of gold. So the guy cheated him. Instead of putting it 100% gold, he did, let's say, 90% gold. They cheated him out of 10% gold. They used a cheaper metal, like silver. So Archimedes wanted to know, how can I know if this has silver in it? How am I supposed to know? Without destroying it, without melting it down, or, I'm not even sure if it could be avoided when you melt it down. I mean, there are ways, we can certainly do it nowadays, but in those days, in the times of the Greeks or whatever, the Greeks and the Romans, they did not have that technology. So the question was put to Archimedes: how can you tell if this is pure gold or not? Now you can't weigh it because if it has a different volume, it's gonna, they couldn't measure the volume. At a different volume, it's gonna weigh less. Maybe, you might think that a real crown would weigh a certain amount, but maybe a real crown is slightly bigger. So how can you tell? So what he did was he got the density. I mean, the whole story of him running naked from his bath, never mind that. But the point is, he said you can find it by finding the density. Take the mass of it and divide it by the volume. this will give a density. Now, pure gold will have a specific density. Take a tiny, small, like, marble of gold. Get the, take the gram, weigh it, get the volume of it. These are easy enough to do. Divide the grams by the volume, and you'll get the density of gold. Then take the king's crown, get the mass, and get the volume, and see if it's the same density. If it is the same density, you've got gold. If it's of a lower density, that means the mass of this must be less than you expected because it's silver. Silver has a slightly less mass than gold. So he was able to figure out whether the king's crown was pure gold or he was cheated and there was some silver in it. Anyway, that's the density, the mass divided by the volume, and it is characteristic for any substance. Now, they might be very close to others. Some might be very close to others, but we would assume that if they are different, they will have different densities. It's easy to measure the mass and the volume. To measure the mass, use a scale, a mass balance, whatever you want. There are many ways to measure the mass. And to measure the volume, use a graduated cylinder. What that is it's just a big cup, you can say, that has little lines on it that the water level reaches a lower line. You put something in it, the water rises to a higher line, and there you have your measurement of your volume. So that's very easy to do. The thing is that volume does change slightly with temperature. I mean, depending on what you're dealing with, some things change a lot more with temperature, but volumes do change with temperature, so best to take all these volume measurements at the same temperature, which is room temperature. Now, there are metric system temperature measurements. Those are Celsius, and that is what is used when we do in all science. We use the Celsius, and we can also use Kelvin, which is related to Celsius, but I'm not going to go into that. We would not use the Fahrenheit that is used in the American system or the English system. Okay, that is enough about the matter and mass and measurements. Let's talk more about light and glass, because that one of the greatest things about glass, that light goes right through it. So we are going to talk about a little bit of the interaction of those. The fact is, when light goes through air, it has a certain speed. When light goes through something that's see-through, that's not air. It has a different speed, and because of that, it will bend as it goes from air to water. And you can see this when you look at a pole in water. If you look at it straight down, you see how the water makes it bend a little bit. So light does bend when it goes from one medium, one place it goes through, to another, from air to water. Incidentally, hot air, it also goes through hot air a little bit better than it goes through cold air. So it'll bend. It'll bend if you have a hot air on bottom and cold air on top. Light will actually bend as it goes from the higher air, the colder air, to the hotter air. And this, by the way, is why mirages happen. Because light, you think you're looking straight, but the light that's hitting your eye is not going straight. It's actually bending as it's going from the hot desert floor, higher up, where it's cooler, and it's bending. So you think you're looking at the floor, but you're actually looking at what might be the sky or something else that makes it look like there's water on the ground, but really there isn't. That's the mirage. Anyway, so light does bend a little bit when it goes from